A 90-foot wall of water is racing toward the Oregon coast, and nobody sees it coming. What happened next would leave scientists speechless, communities shattered, and everything we thought we knew about coastal safety completely rewritten. This is the story of a disaster that defied every prediction. A night when the Pacific Ocean unleashed something unprecedented, something that experts said should not have been possible. Yet it happened, and the consequences are still unfolding as we speak. It started like any other winter evening along the Oregon coast. The sky was gray and heavy with clouds. Fishermen were wrapping up their work at the harbors, preparing their boats for another round of seasonal storms. Locals gathered in cafes near the water, sharing stories and talking about the weather. They had lived through countless winters here. They knew the rhythm of the sea. They trusted the familiar pattern of storms, the reliability of forecasts, and the strength of their seawalls. For generations, these defenses had held. For generations, the ocean had followed predictable rules. But, on this night, the ocean was about to break every rule it had ever followed. As darkness fell, something strange began to happen far out in the Pacific. Scientists at the Pacific Northwest Seismic Research Center started noticing unusual signals coming from their ocean sensors. These devices, positioned miles offshore, were sending back data that made no sense. The readings showed erratic pulses. Seismic tremors were rippling beneath the water. At the same time, a massive winter storm system was intensifying over the open ocean. These two events should not have been connected, but somehow they were. Dr. Marcus Holloway and his team were the first to recognize the danger. They flagged their readings with a term that would soon become chilling in its accuracy. They called it an unprecedented convergence, a warning to anyone who understood the volatile history of this coastline. The numbers kept climbing. The data kept defying explanation, and the question hanging in the air was almost too terrifying to speak aloud. Could this combination of forces supercharge the waves heading toward shore? The answer was yes, and the coast was running out of time. On land, officials began issuing watch advisories, but they hesitated to call for evacuations. The horizon looked calm. The sea appeared peaceful. There was no obvious sign that anything was wrong. But beneath that deceptive stillness, forces were gathering that would soon tear the coastline apart. As midnight approached, nature itself seemed to sense what was coming. Dogs along the coast began barking at the surf for no apparent reason. Seabirds that normally stayed near the water suddenly gathered inland in unusual numbers. Residents who had lived their entire lives by the sea felt a strange unease growing in their chests. There was a hum beneath the ground, an unnatural charge in the night air. Something was deeply wrong, but most people could not identify what these signs meant. Not until it was far too late. The official records would later state that the disaster struck before dawn. But the truth is more haunting. It began in the restless hours of early morning, while the coast still slept, as the first massive surges advanced unseen beneath the cover of complete darkness. At exactly 4:17 in the morning, sensors recorded something that made operators freeze at their screens. A single wave, measuring close to 90 feet in height, was moving toward the shore near Newport. 90 feet. That is taller than an 8-story building, a vertical wall of water illuminated only by pale moonlight, advancing with terrifying speed and unstoppable force. In moments, the ocean pushed hundreds of yards inland. Dunes that had stood for decades were erased in seconds. Roads disappeared beneath churning water. Parking lots were swallowed whole. The violence of the impact astonished even the most experienced observers. People who had weathered countless storms said they had never witnessed anything like this. Eyewitnesses compared the sound to an explosion. Houses shook on their foundations. Windows blew out from the pressure. Seawalls that were supposed to protect coastal communities fractured like glass. In Yakuts, long stretches of shoreline vanished entirely beneath water and debris. Vehicles were flipped over. Cabins were dragged off their foundations and carried away. On the headlands, the resonance of the crashing waves was so powerful that it seemed to shake the very earth itself. The first emergency calls came flooding in almost immediately. Dispatchers were overwhelmed within minutes. One caller from Florence managed to get through with a trembling voice. "The waves keep coming," she reported. "Roads are gone. It is like the ocean is erasing the land." In Depot Bay, the boardwalk was torn apart by the force of the water. Lifeguards and first responders found themselves trapped between surging waves on one side and collapsing ground on the other. They rushed frantically to account for missing residents as more walls of water battered the coast again and again. But perhaps the most unsettling detail for officials was the silence that had preceded the disaster. There was no clear warning. The ocean typically foreshadows its fury. Barometers drop, winds begin to roar, tides rise in predictable patterns, trees bend. These are the signs that coastal communities have relied on for generations to know when to evacuate. But, on this night, none of those signs appeared. The blow landed suddenly, violently, and completely outside the boundaries that anyone had believed possible. By the time dawn broke, the scope of the devastation was impossible to ignore. This was not merely a severe winter storm. This was something far worse, a catastrophic convergence of rare Pacific storm energy, amplified by seismic unrest deep beneath the ocean floor. Oregon's treasured coastline, stretching from Brookings in the south to Astoria in the north, had become ground zero for an event that scientists had thought existed only in theoretical models. Dr. Marcus Holloway himself said something that would later be quoted in reports around the world. He said this should not have been possible, but it happened. And now it redefines the limits of what we expect here. The question that arose again and again in the aftermath was simple but deeply troubling. How could the ocean turn so violent? The answer was not simple at all. The forces driving this disaster were greater than wind and water alone. As news helicopters circled ruined highways and flooded neighborhoods, researchers began piecing together what had actually happened. Two principal forces had combined to create this catastrophe. The first was an explosive winter storm system that had intensified rapidly over the open Pacific. The second was renewed seismic activity on the ocean floor. In the days before the disaster, sensors had picked up an accelerating vibration deep beneath the sea. It was like a distant drumbeat, faint but persistent. Scientists now understood this as a warning of instability along regional fault lines. Marine researchers traced tremors that were strong enough to rattle windows in coastal homes, strong enough to make glasses vibrate on kitchen shelves. Communities up and down the coast had felt these subtle signs without understanding what they meant. At the Cascadia Oceanic Institute, Dr. Abigail Renard and her team worked urgently to connect the threads of data. What they discovered was alarming. "We have seen big waves before," Dr. Renard reported in the immediate aftermath. "We have seen tremors before, but never together, and never amplified on this scale." Her team traced the roots of the disaster to a sudden and severe atmospheric pressure drop over the Pacific. This drop occurred at almost exactly the same time as the seismic activity offshore. When these two events coincided, they triggered what oceanographers call a compound surge. This is a phenomenon where multiple forces combine to multiply the destructive capacity of waves. Heights and speeds exceed anything that standard models can predict. The implications were terrifying. The offshore winter storm, locked with warm and unstable air, had propelled long-traveling swell trains across the ocean. These waves grew in size as they crossed deep water. When they finally encountered the seismic disturbances near Oregon's undersea faults, the result was devastating beyond imagination. Waves of unprecedented power slammed into the coast, overwhelming every planned barrier and every warning system in existence. Automated buoys offshore had tried desperately to relay information, but as Dr. Renard pointed out, the window between detection and disaster had shrunk to mere minutes. Normally, our systems can see the risk develop, she explained. Today, the events outpaced even our fastest alerts. By the time the warnings went out, the damage was already done. For coastal Oregon, this event posed the biggest test yet, not just to budgets and infrastructure, but to the very scientific assumptions that had guided the region's understanding of its own vulnerability. As the day unfolded and scientists unraveled the data in real time, a troubling consensus emerged. This disaster, while technically possible in theory, had been considered almost beyond rare probability. The chances of it actually occurring were supposed to be vanishingly small. And yet, it had occurred, with tremors still faintly registering out at sea, which raised an even more disturbing question. Could greater threats still be lurking beneath the waves? If you are finding this account gripping, take a moment to hit that subscribe button and the notification bell. That way you will not miss our ongoing coverage of events that reshape our understanding of the world. The devastation reached far beyond battered neighborhoods and cracked seawalls. With every tide, the land itself began to falter. At Gearhart, a stretch of dunes that had protected the community for decades became a ragged lagoon by midday. Salt water poured through broken barriers. Tree roots were laid bare as homes hung perilously close to the edge of new cliffs that had not existed the day before. Officials in Tillamook reported that parts of the coast highway had collapsed directly into the churning surf. Waves were gouging new inlets right before the eyes of stunned onlookers. Warnings escalated with each high tide. Emergency crews struggled desperately to keep pace with the destruction. Entire villages were cut off from the outside world. Lifeboats navigated through flooded streets, fishing stranded families from second-story windows. Familiar roads had become unrecognizable rivers of waves and floating debris. The landscape was transforming in real time, but a less visible danger was emerging below ground. Along vulnerable bluffs, Dr. Victor Yang and local geologists began recording subtle but persistent ground movements. Areas that had been battered by waves were starting to slip. The movement was incremental, just inches at first, but it was detectable. Tremor signatures that had been dormant for years were suddenly surfacing as the landforms themselves began to shift.
"We are not just fighting water,"
Dr. Zhang explained to emergency coordinators. "The coastline itself is moving. Erosion, hastened by the seismic episode, is advancing faster than anyone planned for." The immediate crisis was overwhelming. Flooding, destruction, rescue operations stretched to their limits. But scientists warned that the lasting threat might be something far more insidious. Hidden beneath the visible disaster, subsiding earth, creeping landslides, instabilities that would trouble these areas for months or even years to come. In Arch Cape, cliffside homes that had stood for generations lost entire gardens overnight. The ground simply fell away into the sea. In Gold Beach, neighborhoods were evacuated, not just because of flooding, but because of the risk that the land itself might slide into the ocean with the next fresh tremor. Above the battered coast, other disasters began to compound. Power failures spread as seawater invaded substations. Weakened transmission towers lost signal. Floodwaters isolated entire towns from communication networks. In command centers, emergency managers introduced a new term to describe what they were facing. They called it a compound hazard event, a situation where water, earth, and wind joined forces in ways too complex for any standard response protocol. Evacuations were ordered farther inland than anyone had ever anticipated. The safety zones that had been defined by decades of planning suddenly seemed dangerously inadequate. Everything was being rewritten in real time. As the day faded into night, a deeper anxiety crept over the region. If the Pacific Ocean could orchestrate this convergence of forces once, what might another season bring? Were isolated disasters now a thing of the past? Had they been replaced by a new reality where risks interact, amplify, and sidestep every familiar pattern? By midday of the second day, all sense of normalcy along the coast had evaporated completely. Zones that had been labeled low risk for decades were now facing the raging sea. In Seaside and Cannon Beach, homes and businesses that were supposedly built above safe lines encountered floodwaters they were never designed to withstand. Sections of Highway 101 that had been rebuilt after earlier storms failed in moments. At Manzanita, a once stable stretch of roadway broke away beneath relentless wave attack. Drivers found themselves halted just inches from new cliffs that had been solid pavement only hours earlier. Schools in Rockaway Beach became makeshift shelters. They were cut off from the outside world by floodwaters and downed communications. Teachers and staff did what they could to comfort frightened children while waiting for rescue that seemed endlessly delayed. But what haunted officials most was one simple reality: the sheer unexpectedness of these events. For years, infrastructure had been planned according to patterns reflected in the past. Surges were supposed to be rare, floods were supposed to be manageable, land shifts were supposed to be slow and gradual. This disaster changed all of those assumptions in a matter of hours. Every traditional forecast, every map of safe ground, all of it was overrun by reality. Dr. Abigail Renard emphasized this point in an emergency field interview conducted while water still flowed through the streets behind her. "Our systems are built for single hazards," she said, "not for multiple events converging at once. When storms and tremors happen together, our calculations break down completely. We need new strategies. Urgently." The implications extended far beyond immediate response efforts. Insurance policies written years ago now seemed woefully inadequate. Zoning regulations designed for a different era appeared almost naive. Even evacuation plans that had been drilled and practiced suddenly seemed outdated. Lawmakers and officials were forced to reconsider not just how to repair the damage, but how to fundamentally reshape coastal living for an uncertain future. At the water's edge, residents faced a choice that had never seemed so stark: adapt to these emerging threats, or risk losing everything to the next storm. Slowly, painfully, old certainties were fading away. The reliance on generational memory, the comfort taken in concrete barriers and elevated foundations, all of it was being replaced by new questions that had no easy answers. How can communities design for resilience against threats that are more unpredictable than ever before? If these events are just the beginning of a new pattern, what further storms might be waiting offshore right now? Through the evening, it became evident that the ocean was not finished remaking the Oregon coast. This was not a single wild surge or a brief moment of chaos that would quickly pass. Each new tide compounded the destruction. Water pushed deeper inland. Land destabilized further. Erosion ate away at foundations still waterlogged from earlier waves. The Portland Coastal Research Center, guided by Dr. Elsa McGregor, reported the situation with increasing urgency. There was no break between surges, no chance for drainage, no opportunity for repairs, no reprieve of any kind. Instead, each tidal cycle trapped more water farther inland. Rivers that were already running high from weeks of winter rain began to reverse their flow. The advancing ocean tides forced them backward, pushing saltwater up into riverbeds and filling low-lying valleys that had never been threatened before. Inland areas miles from the sea began to flood from underneath as seawater backed up through drainage systems designed for a very different reality.
Compound hazard is an understatement, Dr. McGregor's team warned. We are seeing wave surges, persistent flooding, and seismic ground shifts all occurring simultaneously. Each crisis feeds the next in a destructive feedback loop. If one defense fails, the others quickly follow.
That phrase began appearing in official briefings. A feedback loop of disaster. Wet hillsides that had absorbed weeks of rain began to crack and slip. They were battered by precipitation from above and invaded by saltwater from below. Even inland towns that had never worried about the ocean before prepared for evacuation as rising waters overtook familiar drainage patterns. Night closed in on a coastline that had been transformed almost beyond recognition. Satellite images captured the reality in stark detail: washed-out highways, reshaped estuaries, drowned forests. Search and rescue crews cautioned that entire neighborhoods might remain cut off and inaccessible for days to come. And, with tremors still occasionally shaking the ground beneath their feet, there was no assurance that the worst was over. A deep sense of uncertainty lingered over everything. If forces this rare can collide once, could it mark the start of a new era? An era where ocean, weather, and geology intertwine in ways we have never seen before? An era where the old patterns of prediction and preparation no longer apply. Now, in the quiet aftermath of this historic assault, communities are looking outward. They watch the ocean. They study the unsettled sky. They listen for any movement in the ground that continues to shift beneath them. The damage is everywhere. Splintered boardwalks, lost roads, crumbled seawalls. Families carrying whatever possessions they could save as they seek shelter in schools and community centers. Nature has redrawn the map of this coastline, but the deeper impact may be psychological. The Oregon coast has long been defined by enduring traditions, by the seeming permanence of rugged headlands, by communities that have weathered storms for generations and emerged stronger. But this event has shattered that sense of permanence. The rules are changing, and no one is entirely certain what the new rules will be. Community leaders are turning to scientists for answers. Residents are turning to one another for support. Everyone is asking the same question: how can we defend a shifting coastline when risk no longer follows familiar cycles? When disasters can emerge from combinations of forces that no one predicted? Dr. Marcus Holloway, standing amid the remnants of a field station that had been swept away by the waves, captured the new challenge facing this region. "We are in a new era," he said. "Every protective measure we relied upon, every map, every wall, every dune, every geological assumption, has been stressed beyond its past limits. The future depends on what we learn from this, and how willing we are to prepare for the unknown." Yet amid the broken landscapes, something remarkable is emerging. Resilience. Neighbors who have lost their own homes are helping others. Volunteers are shoring up makeshift barriers along threatened streets. Urgent efforts to adapt and rebuild are accelerating even as the ground continues to shift. Scientists now say the Oregon coast has become a lesson for the entire world, a warning about what happens when rare disasters overlap and the margin for error disappears entirely. The ocean must be seen anew, not just as a beautiful backdrop for vacation photographs, not just as an adversary to be held back by concrete walls, but as a powerful and evolving force, one that exists in constant tension with the land, one that demands respect, vigilance, and adaptation. As night returns and families regroup in shelters, a quiet vigilance is taking hold. Weather alerts are being heeded more carefully than ever before. Hillsides are being scanned for signs of movement. All eyes remain fixed on the Pacific, watching for any signal that another round of destruction might be approaching, or that the long and difficult process of rebuilding can finally begin. This story is still being written in silt and splintered timber, tracked by satellites orbiting high above, etched into the memories of everyone who lived through these terrifying hours. One fact has become absolutely clear. The Oregon coast will not return to what it was. The landscape has changed. The understanding of risk has changed. The relationship between these communities and the sea has been fundamentally altered. But as long as the community listens to the warnings, learns from the data, and supports one another through the challenges ahead, there is hope. Hope that these lessons will serve not only to help people survive the next disaster, but to help them thrive on a newly drawn edge between sea and land. If you found value in this story, please consider giving it a like and sharing it with others who care about understanding the forces that shape our world. We will continue to bring you coverage of events that matter. And remember this, the ocean never stops moving. The earth never stops shifting. The only question is whether we are paying attention.